Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist working in this industry for 24 years and counting. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Our guest for this fortnight is Shiv Mohan, an esteemed maintenance director at Dubai Tram in ALSTOM. With an impressive background in the rail industry, Shiv brings a wealth of expertise and professional recognition to the table. As a chartered engineer from the Engineering Council UK and a fellow with the Institute of Railway Signal Engineers, he is highly regarded for his technical prowess. Throughout his illustrious career, Shiv has held various pivotal roles showcasing his adaptability and versatility within the industry. Notably, he served as project director with Dubai APM Automated People Mover in operations and maintenance. Moreover, his managerial positions with renowned organizations such as Serco, Bombardier, Atkins, and Delhi Metro have provided him with diverse experience and invaluable insights. Shiv's specialization lies in operations and maintenance, where he consistently demonstrated excellence in managing product and project life cycles. His proficiency in handling software intensive systems in particularly noteworthy. Hi Shiv, welcome to Railway Transportation Systems podcast.
Hi, thank you.
Shiv, before I kick off, can you please briefly introduce yourself and your professional story, please?
Hi, I'm a simple person with problem solving and optimistic approach to deliver the performance. After my engineering degree, I started my career from Delhi Metro as assistant signaling and telecom project manager in 2003. This was a dream project for Indian metros where I learned a lot from great vision of Mr. E. Sridharan and his senior team members. Everybody had passion towards making the dream as reality within record time. We learned very important lesson of taking decision, right or wrong, in place of delaying decision. I worked on ALSTOM and Siemens signaling system on line 2 and line 3. After Delhi Metro, I joined Atkins in Sharjah as senior signaling design engineer, where I worked on signaling design of West Coast mainline upgrade project. The life in Atkins was most learning experience in terms of British Railway practices and signaling standard. Later, I got opportunity to work with Dubai Metro O&M team as ATC and systems manager to lead the longest driverless system in the world and associated communication system and AFC system. This project given me opportunity to mobilize the team from different parts of the world to launch the prestigious project and learn from multinational professionals from around the world. The biggest learning from this project was to lead the multicultural and multinational team in complex software-based biggest automatic system. In 2014, life taken me to lead the O&M of first automated people mover project in Middle East at Dubai International Airport. This project was connecting Terminal 1 to newly built Concourse D, which is must-ride system between both concourses. This project gave opportunity to transit from signaling and system to complete rail system of a transit system, along with OCC operation and safety case holder. This project given insight of airport critical operations and importance of APM system in airport operation. Cairo monorail project also given me opportunity to lead product introduction team, which was responsible for testing and commissioning of rolling stock and other rail systems. The project given me exposure, few first time experience in monorail history, which was biggest learning. In 2022, I was given responsibility to lead maintenance of Dubai Tram project, which is my current project. This is unique project with several great features.
Wow, Shiv, your dedication, passion, and continuous pursuit of excellence are truly inspiring, mate. Keep up the great work. And I appreciate your exceptional journey in the field of transportation and rail systems. It's a key lessons for many out there who are listening to this podcast. Moving in your favorite area of expertise, RAMS. What does RAMS reliability, availability, maintainability, and safety impact the overall performance and efficiency of railway systems?
Well, ramps impact the overall performance of railway system. Quality of service is directly dependent on the ramps figures of a project or product. If a system is having high reliability, availability, maintainability, and safety figures, the performance of the system will be very high, which directly impact client and end customer satisfaction. High ramps figure also help to support and implement maintenance optimization strategies, which reduces life cycle cost. If the RAM figure are sufficiently good and performance is high, help infrastructure owner take decision to extend the life of the product.
Wow, I agree. When RAM figures are sufficiently good and performance is high, it empowers infrastructure owners to make informed decisions, correct? Especially about extending the life of the products, fostering long term efficiency and success for the railway system. So, what do you think the key element considered when assessing the reliability of railway equipment and components in RAMS analysis?
When assessing the reliability of railway equipment and component in RAMS analysis, specific focus is given to the failures of the system that lead it to be unable to perform its functionality. These failures are the deviation from the specified behavior or functionality caused by a fault or error in the system. The key elements considered are mean time between failure, mean distance between failure, mean time to failure, mean distance to failures, mean uptime, failure rate. It is time dependent and represents the probability that an element that has been operating for a period of a time will fail within a certain interval. Different projects follow different key elements to assess the reliability.
Wow, thanks, Shiv. Thanks for sharing key elements. You have elaborated, but in short, the most commonly we people know it as MTBF, MDBF, MTTF, MDTF, and MUT. And failure rate demonstrates accuracy and precision is evaluating reliability. Now, after you discussing this, how does RAM analysis contribute to enhancing the safety standards of railway operations and minimizing potential risks?
Okay, RAMS analysis focuses on reliability, availability, maintainability, and safety. The goal of this analysis is to provide smooth and safe operation to end customer, which is passenger. High reliability and availability figures ensures that rarely system go into degraded and emergency mode, where most of the railway operation risk comes into the picture. For an example, let's consider the CBTC system where train becomes non-communicating due to failure of zone controller and train need to re-enter into the system by driving in manual mode under manual route reservation. The risk increases as manual intervention is increased, and if this occurs frequently, the risk profile of the system will be much higher. If the reliability is good, these risks are minimized and safety of railway operation is high. If the maintainability of the railway equipment is good, the maintenance staff will have less risk to maintain the system. Safety analysis itself ensures the standard of safety for passengers, staff, and infrastructure. Safety analysis ensures that any risk is identified, analyzed, and mitigated to as low as reasonably practicable level, which is called alarm.
Wow, key points, Shiv. I'm really glad you came onto this show. Good maintainability reduces risks for maintenance staff, ensuring efficient system upkeep. Wow, I'm learning. Safety analysis guarantees standard safety levels for passengers, staff, and infrastructure. Wow. Since you worked a lot in maintenance division, can you explain the role of maintainability in RAMS and how it influences the maintenance strategies for railway assets, please?
As a maintainer, the maintainability of a system is ensured by detectability, ability of the diagnostic system to isolate the source of failure. Also, accessibility to installations, modularity, and interchangeability of components and logical management of maintenance. All these aspects together give a high maintainability. Some of the key elements for maintainability are component repair index, mean time to repair MTTR, and mean downtime MDT. If design for maintenance is considered during preliminary design and detailed design and equipment maintainability is high, it makes life of soft floor employee easier. The downtime of the asset can be reduced and uptime can be increased as maintenance can be done easily. As public infrastructure like railway requirement is getting critical in most of the busy cities, there is increasing demand of running network for 24 hours. In few of the public railway network, railway system is operated 24 hours. For example, few airport people mover is operated the whole day and night. There is high requirement of maintaining the asset in minimum time, which is dependent on system maintainability. In case of one system failure, maintainability ensures that affected system isolate itself and does not impact the full system working. MTTR is reduced based on better system modularity and interchangeability of components.
Wow. I have noted down a point. Better system modularity and component interchangeability contribute to a reduced MTTR. Since we are on MTTR topic, Shiv, could you share some real world examples on how RAMS practices have helped optimize railway operations and reduce downtime?
Well, a strong RAMS analysis has helped several projects to optimize railway operations and reduce downtime. We have optimized system maintenance in Dubai APM due to outstanding RAMS practices and high RAMS figures. High reliability has helped us to take informed decision to delay few of the maintenance tasks. The railway system must achieve the RAMS requirement during the trial run and before start of passenger service, as establishes the path of optimized railway operation. High reliability and availability of system and good RAMS practices minimize the requirement of secondary systems, which unnecessarily makes the product costly and increase the life cycle cost of the product. Dubai Metro and Dubai APM has not used secondary detection system for signaling system due to high reliability and availability of its primary detection system. High availability figures in range of 99.9% demonstrate that downtime is significantly reduced thanks to the reduced MTTR due to system modularity and interchangeability of components. Reliability management through Webull analysis provides accurate failure analysis and forecast with extremely small samples. It helps to ensure that spares are available in time and downtime can be also avoided, including logistic management is taken care. With the help of this analysis, any significant impact on passenger service is avoided in several projects worldwide.
If I'm listening to this and I made some notes as well, it means that reliability management, particularly through Webull analysis, provides accurate failure analysis. And now this ensures timely availability of spares and minimizes downtime. Thanks for sharing this, Shiv. I think this is the secret recipe. Now I got another important question on RAMs. How do railway RAMs requirements differ between new infrastructure projects and existing railway systems, and what challenges might arise during implementation?
RAM's requirement is required to be taken care in full project cycle. According to SNELAC standard EN 50126, RAMs plays a role in each phase of project cycle, starting from concept design to manufacturing to operation and maintenance. During system design, RAMS analysis is performed using FMEA and FTA method in consideration of system boundaries like system description and operational environment. Hazard and risk analysis is performed including reliability, availability, and maintainability analysis. RAMS analysis provide key results like life cycle cost analysis, which define the maintenance strategy, and key element like MTBF, MTTF, etc., which set up the requirement which need to be met during testing, running, or system demonstration performed by design and build contractor, and also trial running performed by operation and maintenance contractor in attendance of DNB contractor. These requirements need to be fulfilled to ensure that product and equipment can provide required output to provide safe and smooth passenger service. Few challenges during implementations are like the RAMS requirement is mostly theoretical and practical aspects and recs from previous similar projects are mostly not taken into consideration. Another one, sufficient time is not given to prove and validate the RAMS requirement during testing and commissioning and system validation phase. Everybody is looking for to complete the project as soon as possible. Samples taken to validate the requirement often not sufficient. Organizational culture, sometimes organizational culture makes a lot of difference. While existing projects in operation and maintenance phase had different requirement to meet system availability to serve the passengers, the RAMS input to O&M phase comes from new build RAMS study and demonstrations. RAMS and safety studies are performed to validate the system performance according to design phase calculations. The goal in the phase is to continuous improvement of performance and to reduce the operational cost. In this phase, RAMS data is collected and compared with DNV phase RAMS requirement data and analyzed whether system is achieving the requirement or not. In case of the RAMS requirement is being met, the objective is to extend the performance by additional methods. If the system is not performing as per RAMS requirement, all efforts are made to reestablish the RAMS requirement. It may require design change, addition of new technology, etc. The main challenges in the O&M phase are like reliability management data slip unnoticed in the process of control of maintenance cost. Human reliability, how the person who is collecting the data, how much he is reliable, how he is collecting the data. Standardization and normalization of collected data. The data is collected, but whether it is standardized and normalized based on the different project. Quality of data collection. CMMS system and asset management system are underused. Most of the project they have deployed heavy maintenance management system, but they are not utilized. The data is not being analyzed. Lack of data on degradation of different components of the infrastructure. Asset degradation rates are slower. It needs patience and some time for data collection.
Wow, outstanding answer, Shiv. Your diligent approach to RAM analysis, especially during the O&M phase, is truly commendable. Your focus on continuous improvement and cost reduction demonstrates your commitment to delivering efficient railway services. So, you mean by collecting and comparing RAMS data with the DNB phase requirements, you efficiently assess system performance and take the appropriate measures accordingly. After all this discussion, I would like to focus on strategies and best practices. What are the key strategies and best practices employed in railway maintenance to ensure optimal system performance, reliability, and safety?
Well, key strategies and best practices to ensure optimal performance in maintenance can be several. It can differ from project to project, can differ even though from person to person, leader to leader.
Yeah.
I would like to discuss few. Implementation of competency management system is key, which is mostly ignored, so that maintenance team is competent. Deployment of stringent safety management system, process and procedure is must. Rollout of effective program of regular assessment, audit, drill to ensure that laid down system is working and what to improve further. The continuous improvement mindset is required. Data collection is the responsibility of everybody in operation and maintenance, not only technician and operator. Data must be continually monitored for both quality and relevance. Once the data flow is developed, can be used in several areas such as developing preventive maintenance program, predictive maintenance, warranty administration, tracking vendor performance, and improve decision making. Digitalization, use of disruptive and transformative technology like IoT, digital twins, big data analytics, they are the requirement for the future to optimize the performance.
Brilliant, Shiv. I really appreciate your first point where you mentioned competency management. I really concur with that. And rolling out of effective programs for regular assessments, audits, and drill really showcases your dedication to continuous improvement and you believe in the system reliability. So, especially what I noticed is you emphasized on continual monitoring data. With all this discussion we had so far, let's talk about the end user who is our operator. How do railway operators manage and coordinate operations in a large scale network to maintain efficient train schedules, minimize delays, and handle unforeseen disruptions effectively?
Okay, there is a big challenge of increasing customer demand and expectations for railway operators, and they are continuously bringing improvements to manage and coordinate operations in a large scale network. Operators are utilizing real time traffic and rail system data, whether it is coming from signaling, rolling stock, and other systems, to take fast and real time decisions to provide higher system availability. Centralized data collection and processing is also making difference. Close coordination with different stakeholders and use of centralized command control center to manage unforeseen disruption. The use of predictive technology, machine learning, and artificial intelligence is helping them to take effective and critical decisions. The collaboration between different operators for benchmarking against world-class best practices is being used to learn from each other. Use of advanced driver assistance system, use of intelligent transportation system for vehicle to vehicle communication is going to be key for the future. Improved CCTV coverage on the network to monitor better and detect incident, illegal intrusion on railway infrastructure is going to help operators. Arterial network monitoring to identify unusual conditions, incidents to ramp up the response speed, like use of weather stations. If there is a sandstorm, if there is a thunderstorm, there is a big typhoon, operator can take the decision. Effective planning and permit to work system for different works on the network is critical and it is being used in different infrastructure.
Oh, I agree that. Shiv, the strategies you highlighted, nearly 8 to 10 points, I believe, ensures a more responsive, efficient, and customer focused railway network. Wow, I should say well done. Thanks for sharing such valuable insights. Before I let you go, because I think we covered nearly 11 questions and my podcast time is only 30 minutes, could you please give us one piece of your advice?
I will be short as we are overrunning the time. Railway is the future for sustainable earth, and we all current railway practitioners have huge responsibility to attract our future generation towards the railway industry. Let us improve the attractiveness of railway to make it more appealing for the future generation so we can serve our mother earth better. Thank you.
Brilliant, brilliant advice, Shiv. I completely concur with your advice by focusing on enhancing the appeal of railways, which I'm really fond of. You are paving the way for brighter and more sustainable future for generations to come. Thank you, Shiv, for your time today. It's been a pleasure talking to you.
Thank you. Thank you, Rahman. I
Believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry. Contact me on railway transportation systems at gmail.com. Thank you for your time today. See you next fortnight. Until then, stay safe and take care of yourself.